Also related to strings and string operations are the different commands, functions, which are exposed by the FMT package. Up to this point, we always worked with println, but there are a couple of other functions available as well, which can also come in handy from time to time. The format package offers a broad variety of functions, of commands that we can execute that help us format and or output text. For example, we have a group of print commands, and here we see the println command at the very bottom, which we used all the time. But there are other print commands available as well. For example, just print without ln and printf, which works a bit differently, and we'll dive into it in just a second. And there also are other command groups made available by the FMT, the format package. For example, the sprint commands, sprint, sprintf, and sprintln, and the fprint commands. Now, the difference between these different groups is that the left group, print, printf, and println, directly output a value in the command line, so that we can see some output if we run our go command. Sprint, on the other hand, instead produces a new string that we can, for example, store in a new variable. So that will not output it, it will just produce a new string. And fprint also produces a new string, but then writes it with help of a so-called writer, which is a bit more advanced, but for example can be used to write into a file or send back a HTTP response. We'll explore it later. Now, besides the different ways of doing something with that string, key differences inside of these groups are also how that string is formatted, because that's another thing those different commands do. For example, the println command and all these commands from the different groups that end with ln formats the output such that a new line is entered thereafter. So if you println multiple times after each other, as we did it in our code in this section already, then every output receives a new line. If you just use print, that would not be the case. There would be no line break added into the formatted string. With println it is. But especially powerful are the printf, sprintf, and fprintf functions here, because they give you full control over how a string should be formatted. And let me show you what I mean and how that works. At the moment, we always used println to simply just output a string like that. Now, what if you want to embed a value into some rich text? For example, here I could create a full name variable instead of outputting it just in place here, and create that variable like this. Now, of course, I can print full name. But what if I want to say, hi, my full name is, and then I want to output full name? We can do this by creating a new string just in time here, where I say, hi, my full name is, and then I concatenate full name like that. This white space here is also important so that there is some space between is and the full name. If I do that, and I then run this again, I do see this sentence down there. This works and is fairly trivial here. It gets more annoying if our variable is not at the end or beginning of the sentence, but in the middle of it. For example, I could also have my age stored here, which is 32, which is an integer. And I then might want to extend this sentence to also say, and I am, and then I want to include my age here, and then I want to say years old. And now I even have a problem that age is an integer, and I'm combining it with a string, and we learned before that we can't just do it like that. That's where other versions of this print command can come in handy. If we don't use println but printf, then we can produce strings with embedded values in a way easier way. We still create our string here where I say, hi, I am, and then my full name. I'll just keep this empty for now. And then I could say, and I am, and then I say years old. And now in place of these placeholders, we can use special identifiers here because we're using printf, which start with a percentage sign, and then, for example, percentage sign v to output the value of some variable. And we do that here as well. And now we just need to let Go know the values of which variables should be output here. And we simply add those extra variables in the same order as we're referring to here in the string as extra arguments, as it's called, to that printf function by adding a comma, and then the first variable, which value we want to output here in that first place, which is full name, and then the second variable, age, separated by another comma. And here it doesn't matter that age is an integer, because when we do that, when we use this printf function, we just tell Go that it should actually extract the value as a string from that variable. And it will then convert this integer to a string internally. If we now save that and we run this again, we have that same sentence as before with that integer included as well. And we get that with help of this printf function, which allows us to output a text, a string, with dynamically injected values. And it's not just values which we can inject, though that is a very common use case. You can also inject other pieces of information, for example, the type of a variable. If I would want to include that here, maybe in parentheses inside of this string, where I say type colon, you can get access to the type of a variable by using percentage sign $t. And then again, since I'm now having a third placeholder in this text overall now, I need to add a third value down there at the end, separated by a comma, and that's again age. Because here, the first time I'm referring to age, I'm adding it for this value which I want to get, and then the third placeholder which I have in this overall string wants to get the type of a variable, and hence my third variable which I reference here at the end, again is age, if I'm interested in the type of age here. And now if I would run that, I also get type int as an output down there because of this special percentage sign $t placeholder. Now attached you find a link to the official documentation of the format package where you learn which placeholders are available and what they do. As you see, there are various options for outputting various pieces of information, and this is simply a very useful and common function or command which you use to output formatted strings. Now, if you don't want to output the string in the command line, but instead you maybe want to produce such a string like that to then store it in another variable, for example here, to avoid this concatenation, you can use other commands from the format package. That's what I also mentioned on this slide. For example, the group in the middle, sprint, sprintf, and sprintln, also produces strings but does not output them in the command line immediately, but instead returns them so that you can store them in new variables or existing variables. And we could utilize this here when we create full name. Instead of creating it as we did before, which maybe is a bit inconvenient, we could use format sprint or sprintln if we want to force a line break thereafter, and then just add our different strings as comma separated values here. First name, comma, then the white space, and then last name. That would be one way of doing it. Or we use sprintf, and instead we use the same formatting syntax we have down there, where we simply have the first value, then a white space, then the second value, and then we have first name and last name as comma-separated values at the end. If I do that and I then run this, I still get I am Max Schwarzmuller, so I still get my full name here, but now it's created with help of sprintf. And since that returns the string instead of outputting it in the command line, we can store that returned string in that full name variable. And these are a bunch of very common operations, which you'll see all the time when you work with Go and therefore also throughout the course, which is why I wanted to get them out of the way here. You should understand what this format package in general does and why we have println, printf, and then also sprintf and sprintl and so on. It's only the last group here, fprint and so on, which you don't need to understand 100% yet, since we'll see that in action a little bit later in the course. We gained more knowledge, and again it's time to practice what we learned. Here's another exercise for you, and again you find the exercise 2 zip file attached, which contains this instructions text file. Extract it, add it into a brand new empty folder or wherever you want to do your exercises, and then follow these instructions. You should first of all create a new Go code file and initialize it as we did it before in this section as well. And then in task number 2, I want you to create 2 new variables in that file. The first variable should hold the number pi, and you should name the variable appropriately and store 3.14 in it. The second variable should be the radius of a circle and should hold a value of 5. And you should make sure that you pick appropriate types for those variables if you don't let Go infer them anyways. If you do, then of course go with those inferred types. Now in task number 3, you should then calculate the circumference of a circle. Whoops, that should be circle. And you find the formula here, in case you forgot it from your math class. And you should store that circumference in a new variable with an appropriate name. Now also output that value in the command line thereafter, and of course make sure that that value is correct. And you might have to do some type conversions here. Well, basically apply what you learned over the last lectures. As a side note, you might see a tiny precision issue once you output the result. You can ignore that. In task number 4, I then want you to format the output a little bit. And you should basically output a string that says something like this. So some longer text. And x and y should of course not be x and y, but concrete values, which are part of that string. And you might need to look at this URL to find out how you can output a number with decimal places such that only 2 decimal places are shown. Or you scroll to the bottom of this file, there you'll find the solution as well. These are my tasks for you. Again, it's only what you learned in the last lectures, but definitely try it on your own first, but then also have a look at my solution to compare yours to it.